afternoon.
Good afternoon.
Now, you just testified, sir, that according to you, your reading of an EPA report, that normally you will find no more than 2 or 4 parts per billion EDTA in a normal person's blood. Is that what you just said, sir?
Yes, that the normal is no more than 4 parts per billion. No, right.
Okay, no more than. In other words, you're saying that the maximum amount of EDTA that you will find in a normal person's blood is no more than 4 parts per billion, correct?
That's what the EPA says, and I accept that. I have nothing better.
And that's based on a report that you had. Is that correct, sir?
It's an EPA publication, the OMTADs, which is one of their publications.
Now, if what that... Strike that. In the evidence stain, sir, you said you found EDTA in the levels of parts per million, correct?
I didn't find it. Mr. March did, and I agree that they are in the parts per million based on his analysis.
So the amount of EDTA found in the evidence stains on the gate and the sock were in parts per million. Is that right?
Yes, because it cannot detect anything that is less than parts per million in any of the samples that he prepared or tested. His detection limit is in the parts per million.
The answer is yes. The amount that was found in the gate and the sock were in parts per million, correct?
Yes.
And the amount that should be found, the maximum amount that could be found in a normal, healthy person's blood is in parts per billion, correct?
Yes, according to the best available information.
And if that information is incorrect, and the actual information is in parts per million, then the amount found in the gate and the sock are a normal person's maximum allowable amount. Wouldn't that be true, sir?
If the best information is its parts per million, then yes.
I have a report to show you, sir. We received a report. I'm showing the council now. I'd ask if you mark people's necks in order.
I'm sorry? 534. Be careful, Miss Clark.
Let me show you another report. Now, the report that you just pulled out from your briefcase, sir, I'm going to cite you to a passage where it says, in situ amelioration AML, dredge undissolved solid. That's in your report, correct?
That's part of their report. That's part in the copy that I gave you.
This is the EPA report that you used to base your opinion on that the normal amount of EDTA that you'll find in blood, or the maximum allowable amount in a normal, healthy person, would be in the parts per billion, correct?
This and the paper by Trujillo and Foreman is the other author.
Now, with respect to this report, sir, on which you just said you based your opinion from the EPA, you read that to allow for the maximum allowable amount in a normal person to be 2 parts per billion.
Right.
Right. Now, is it possible, sir, that you have a typo here that caused you to conclude there were 2 parts per billion as the maximum allowable, when in fact it is 1,000 times less, 2 parts per million as the maximum allowable amount in a normal, healthy person?
It's possible that this is a typo, but this is a 2,000 parts per million is absurd, as I told you. The people would be bleeding to death at that level.
In other words, if this is the correct EPA report, you disagree with it?
Well, obviously. Obviously it's a typo in there. Because I can't imagine that the EPA would say that it's all right to run around with blood that won't clot.
Sir, you earlier just premised your opinion on the maximum allowable amount for a normal person on the EPA report, correct?
That's correct.
And in your report, it says 2 ng/ml.
Yes.
And you interpreted that to mean 2 nanograms per milliliter?
Yes, it's the only one possible.
That's the only one possible from an ng as opposed to an mg, correct?
That's correct.
And so you determined that what the EPA was saying was the maximum allowable amount was 2 parts per billion, correct?
That they were saying what is consistent with the radioactive study, and that's what they say. Yes, sure.
But the
Makes sense.
radioactive study, sir, was not able to pick up EDTA in the blood, was it?
That's correct.
It gave no lower trace amounts that it was able to detect or measure in blood, did it?
I'm sorry.
That report back in the 50s of radioactive EDTA did not state any specific amount for anything detected in blood resembling EDTA. Isn't that correct?
That's not correct.
All right,
What
object. I thought we weren't going into this. I mean, I'm happy to.
Sustain.
I can't.
Sustain.
What? What was the objection?
Court's previous ruling on this regard, that report.
Analyzed them separately by the mass spectrometer, something which I've done.
You yourself have never operated the electrospray, isn't that correct?
That's correct.
Now, doctor, wouldn't you agree that the person that would be the most qualified to testify and interpret the results of the operation of a given machine is somebody who operates that machine on a daily basis?
He should be the most qualified person to determine what the limits of ability of his machine are, since he works with it every day. Yes.
And in that regard, sir, you testified earlier that you thought retention time was a significant factor in determining whether or not these stains had the same qualities as those found in the reference blood samples with respect to the presence of EDTA. Isn't that right?
Yes.
And if an expert in the operation of this machine, such as Agent Martz, told you that retention time was an inappropriate factor to use because it is not discriminating for the presence of EDTA, wouldn't you agree that retention time should not be relied upon to determine whether or not a substance is or is not EDTA?
Well, if he were to tell me that, I would tell him that he's in error, because retention time is a characteristic of a substance in a chromatography system, provided there is some reasonable reproducibility of flow and other things that's possible. It's independent of the detection system and all these other things, and the variability may be greater in one than in another, but it is usable and it is used for that. Yes, that's what I would tell him. He didn't tell me that it's not applicable. Retention time is always a characteristic of a substance unless you change conditions completely.
Well, let me ask you this, doctor. When you do testing to determine whether or not you think something is present, chemically speaking, wouldn't it be important to use factors that are as unique and as rare as possible in determining whether or not a compound is or is not a given chemical? Wouldn't you agree?
Only if you add the one other thing, and available. If you can do within the framework of what you can do, are you doing all you can to get the most intimately characterizing property of the substance that differentiates it from others? Yes.
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 Doctor, let me ask you this. If you are attempting to find women that look like me, wouldn't it be far more efficient to say you want a woman of this height and this weight, and I'm not going to say what that is, and this kind of hair and these kind of eyes and that kind of mouth and those kind of arms, as opposed to just saying I want a woman 5'6"? Wouldn't you agree?
Sustain.
Is it because of the weight thing, Your Honor?
It's too oblique for me.
All right. What I'm getting at, doctor, is if you use criteria that are very broad, then you will include a lot that does not belong in that category, correct? As a general proposition.
Objection vague.
Forward.
I will use all available criteria, broad, narrow, microscopic, and assign to each one a probative value for what a scientist does, and that is applying what is called the null hypothesis.
All right, doctor, let me ask you this. If you assign probative value, if an expert in the operation of this machine who uses it every day like Agent Martz were to tell you that retention time has very little probative value because all chemicals seem to pass through at almost the same time or within a minute, would you agree, doctor, that that is not a factor that should be given great probative value in your determination as to whether or not a compound is or is not EDTA?
Well, if you were to tell me that, I would tell him that you are grossly mistaken, and if you earnestly believe that all compounds would pass through in a short time when you have a column, you don't know what you're talking about.
But doctor, you would agree, would you not, that someone who runs that machine every day would be a better expert, better able to determine what are the probative factors and are not, than someone like yourself who has never operated it. Wouldn't you agree, doctor?
Oh, well.
He should be, but if he says that, he isn't.
Doctor, isn't it true that most compounds will pass through this particular, the electrospray in particular, in about 1 minute?
They'll pass through the electrospray in 1 minute, but the separation occurs in the chromatography column.
That's right. And in the column, sir, how long does it take, if you know, do you even know how long it takes most compounds to pass through the column in the LC tandem MS?
That'll depend on what column and what flow you use. He doesn't say how much time it takes. He has everything down in terms of scan numbers. So I can tell you, it's a few minutes between runs, and that rather surprised me that so little separation time is allowed. And but that's all. I can't tell you a thing about it. If he knows what he's doing, then he's using a column to separate substances. As far as I know, he knows what he's doing, and that's what he's doing, so he separates them.
Doctor, he conferred with you on at least one occasion, correct?
We talked about this on at least one occasion, yes.
Okay. And as a matter of fact, you've had his reports or his notes and the graphs for months, correct?
That's correct.
Was there anyone who prevented you from picking up a phone to ask him about these questions, sir?
Yes.
Who?
It's not customary for me to do that. I asked the attorneys to get me additional information or to suggest that I call him up and talk to him on the phone. I got additional information, not all that I asked for, but I did not get their okay to call him. And although I realize I can do it, you know, I'm a free man, it's not a very proper thing if you are going contrary to the wishes of the people that you talk to, unless those wishes are an obvious crime or something.
And the defense attorneys told you when to write your report and who you may call and not call. Is that correct?
No.
You wait for their permission. Is that correct?
Not their permission.
Oh,
I do not wait for their permission. I ask them whether they have wishes, not orders. And if their wishes are reasonable, I'll comply with them, of course.
Doctor, you're a scientist, are you not?
Yes.
It's important for you to get as much data, as much information as you possibly can so that your answers are all as correct and reliable as they can be. Isn't that true?
If I can obtain that information properly, yes.
And would it have been improper for you to ask Agent Martz to furnish you with information on the validity or the probative value of retention time, for example, in this particular piece of equipment in which he is an expert in its use?
Objection, argumentative vague as to what's improper, what that means.
Overruled.
Either ask that question specifically or ask it in a more general way, which I did through the attorneys, and that is that I would like to see the validation data for all the parameters that apply to this analysis. Retention time is one of the most important parameters, and the validation data that I received contained retention times which put it exactly into the range that they were. So it worked fine.
Yeah, Doctor, you operate the gas chromatograph, correct?
Yes.
And the gas chromatograph, retention time is a very important factor, isn't it?
in every chromatography, retention time or RF or RT, whatever they are called, it's the same thing. They just attach different letters to them, is one of the characterizing properties of individual compounds, or sometimes of groups of compounds, depending on how you're doing the analysis.
And doctor, in the use of the gas chromatograph, you will be able to detect items by how long they take to separate, correct? And some items take a great deal more time than others.
Not how long they take to separate, but how well separated they are in the run.
By the time they get to the end of the column.
Well, separated somewhere, whether they, by the time they are measured by the time they get at the end of the column, the time is recorded, and the time between one peak and the next peak has to be sufficient so that they are clearly two peaks.
And what is the amount of time, maximum amount of time, that it would take an item to go through your column, the gas chromatograph column?
That is so variable. I have substances that go through the column, through one column in less than a minute. I have others which take 40 minutes in that or in other columns. It is as long as you want it to be. For instance, in the EPA studies, there are runs that are 2 hours long. So, you know, it's what you're looking for and what you're doing. As long as you know what you're doing, you're all right.
All right, doctor, in your experience then with the gas chromatograph that you routinely operate, you can have items that run through the column for as long as 40 minutes, correct? That have a retention time as long as that?
Yeah, I think in one of the types of analysis that we do many different types. There is as much, it's a screen and it extends over something like 40 minutes.
Now, doctor, if Agent Martz were to tell you that because of the way the electrospray works, he's required to use very volatile liquid to push the material through the column, such as ammonia. And as a result of that, just about all substances go through in 1 minute. What, in your opinion, would be the probative value of retention time?
It would still be the retention time of a substance within 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds, 60 seconds. The last one is 6 times as long as the first one. So whatever the time is, I'm sure he isn't pushing it through a column for the fun of it, because if it's so close that you can't differentiate, why use a column at all?
Nevertheless, doctor, if that were the case, then wouldn't you agree that retention time is not a very discriminating factor in the LC tandem MS electrospray?
It is a discriminating factor. I don't want to assign to it very little. It's a discriminating factor. It's a property. It takes a certain length of time for EDTA to go through. So that's one of its characteristics. If he knows of 50 other substances not related to EDTA that have the same retention time, and if he'll tell me, then I say, well, then it still is a characteristic, but it is shared with other substances.
And so
now, if these substances are indeed things that you find in blood, then it's important. If they are substances that you only find in the Gulf of Mexico, then they are irrelevant. Because, you know, it has to be something that has a meaning in terms of the analysis that you do. If they are cyanide and other horrible poisons, then in this case, it's irrelevant because there's none there.
All right. Now, doctor, then in that case, if there were, say, 50 other compounds that passed through at the same retention time, the probative value would be less.
Of course, if you can tell me that that's so, I'd say it's less than if you only know of 2 others.
Well, doesn't the retention time to some degree depend on the kind of liquid used to push the material through the column?
Well,
Isn't that true?
Among other things, of course.
And if you routinely use the same liquid repeatedly, isn't it true, doctor, that you're going to wind up with a lot of compounds with the same retention or very similar retention time, as opposed to using different liquids?
I don't know that. No, you don't have to. You have a good separation or you don't. I don't know.
And you don't know because you don't operate the electrospray, do you, sir?
Well, whether you operate the electrospray or not has nothing to do with that. Nothing whatever. Is if the whole retention on that column is 1 minute, then you're working with the separation within 1 minute. There are gas chromatographs which separate 200 compounds in 1 minute that you put in there. So I'm sure that the same thing can obtain here, although LC is less of a separator.
But you would agree with me, would you not, doctor, that if the retention time in the electrospray is very similar for many different compounds, then retention time is not a very probative factor? Yes or no?
It's a probative factor. Very, what is very? How much?
Well, didn't you just tell us, sir, that you determine how probative certain factors are?
Yeah.
All right. Then obviously there is some variance between the importance of certain factors and others, correct?
Sure there is.
All right. Now, with respect to Agent Marcia's blood, you have testified, sir, that since you wrote your report, you found out that Agent Marcia tested his own blood and came up with characteristics just like those in the gate and the sock stains, which you determined were EDTA, correct?
There are too many questions in there. Let's take one at a time. Would you mind?
Is that an objection compound?
Yes, it is. Sustained.
Well, let me just show you a chart, sir. While Mr. Blazer is reviewing that, I want to show you a chart that he showed you earlier. Did you mark this one? Requires 3 times the signal-to-noise ratio before saying that something could even exist. Have you heard that?
I've heard some people claim that, others 5, others 2, others 10. It depends on the circumstances. This is not from Olympus. The important thing in determining the presence or absence of something is, can you see it above the noise in one way or another?
All right, and when you say can you see it above the noise, you mean that there may be kind of jagged lines like this, but in order to call a peak an identification of something or a detection of something, that one peak that stands out has to be 3 times higher than those other lower jagged peaks. Isn't that correct?
No, actually what is used is not that it has to be so much higher than the noise, but that it has to be higher by more than a certain number of standard deviations of the mean of the noise. That is what is used.
In which case, you would expect, though, to see on the graph one peak higher than the rest. Isn't that correct?
Either that or a pattern which is clearly different and more like something there than nothing there.
All right. Now you're looking at this graph again, sir.
Yeah.
Did you mark it then? What was the mark? What was the mark? 1259C. Now you determined that on this chart is shown the other daughter 132 because at the same retention time, move over. Will you direct the arrow, sir, to where it was before? Tell the arrow where to go. See the arrow? Look on your monitor. Yeah.
How do I do that?
Tell it to go right or left.
Go to the left a little bit. Hold. That's one peak. Go to the right a little bit. No, less than that. Here's another part of that peak. Go to the right. That little more. Little more. That's it.
Above.
Now there's another one. Now let's go to a valley. Go over. No, go to a valley. That's it. Little bit to your left. Now go another arrow a little bit to the right. Okay, that's good enough.
And It's your contention that that proves what?
That the retention time of the first of these arrows is in one of the places where the retention time of EDTA has appeared. You have to bear in mind that this is a scan over an extremely wide range, so that there's very little energy available to scan any one ion. So it is much less sensitive than if you do the same thing and only scan for 160 or for 293, but it's still strong enough to show a pattern which matches that seen in the parent ion and daughter ion chromatogram,
All right. but
which
you
is
would
a
agree-
focus chromatogram.
You would agree, would you not, sir, that the other random peaks there are not 3 times lower than the peaks that you pointed out, correct?
They certainly are not.
All right. Now look down at 293.
Right.
There is a very high peak in the very beginning, isn't there, sir?
The what?
That 293 is the parent ion, isn't it?
Yes.
Isn't it? And you see a very high peak where we've just put the magenta arrow? In fact, that's the highest peak on that graph, isn't it?
That's correct.
But you didn't call that, you did not identify that as the parent ion, even though that does have a high peak, maybe 3 times as high as some of the other peaks on that chart. Isn't that correct?
No, I did not, because I have nothing to go on to call it a parent ion.
Then, in fact, what this graph shows, sir, in your opinion, as the 132, is based solely on the fact that you see something at the retention time.
At the same retention time where I see the 160 and the 292, and at the same retention time where in the more focused chromatogram that we looked at previously, where you can see much better that 160 and that it's in the same place, and even the pattern is somewhat similar. So that's why I say that you saw it before at 160. Now if you're scanning the whole thing, even though it is so much weaker, I mean, this is probably, I don't know, it could be as much as 100 times less sensitive than the 160 ion. You still see it. And in the same place where the 160 is, you also see the footprints of the 132 ion.
And so are you willing to say, sir, to a reasonable degree of scientific certainty, that based on this graph here of the 132 daughter ion, that it is present on the sock? Is that your testimony, sir?
That what is present on the sock?
The 130, that you have the full daughter spectrum on the sock, based on this reading of your graph of 132.
This is the full daughter spectrum on the sock, unless there are other smaller ones, you know, unless there are other little pieces around which are not looked here. And that's, in general, is the weakest, the least sensitive of the methods that he could use, but at the same time, it's more specific. You're trading off one for the other.
All right, Ms.
So
Clark,
is it...
we're going to take a recess at this point. All right, ladies and gentlemen, please remember all my admonitions to you. We'll take about 15 minutes for a break.